Well, welcome everybody. How's everyone doing?
I'm all right. How are you, Amit?
I'm good, thank you.
Um, Dolly, how's your presentation stuff coming?
Uh, yeah.
All right.
Yeah, yeah. No, I finished my software to a point that actually I can use it to do science, so I'm gonna stop developing uh, most of it. So I run the pipeline yesterday. I got results this morning, and I'm gonna present them Wednesday. So it's coming together.
Nice.
Yeah,
That's
that's how quick you can get presentations, like good results now. So quick. No, I'm really impressed actually how it pans out. It's awesome. I'm really enjoying this.
that's why I didn't ever want to go into wet lab stuff because my brother he was doing wet lab junk and it would take him weeks upon weeks just to get results. Whereas you can just run something on the machine and bam.
It, it took me 6 months to write the code. So now that everything is written, yeah, now true. In 1 week you can actually get scientific results enough to present them. But it took 6 months to make the tool.
Well, hopefully your 6 months will help you get like 6 papers in like 1 month or something.
That's the game plan. If that's a good tool, that's how it is, right?
That's right. Make or break it. Yeah. Well,
Exactly.
let's jump right into.
Right.
'Cause we've got a lot of ground to cover here. I went on vacation and I even was able to polish up one little thing while I was there. I'll get to that in a second. But I kind of want to give. Well, I'll just catch you guys up where I am at or what we got. Right before I left, I was able to get PFAM30 integrated into the pipeline, and then even today I made a couple of fixes with Docker, little glitches there. But what this is pretty cool is now, and I don't know if I mentioned this or not, but I got undo and redo in place. So what this means is that if we change our algorithm for doing something, it's super easy to undo those results and redo them with a new algorithm. And it does this on a per genome basis so that we can keep the genome, 99% intact while we're upgrading. And what I mean by that is, the brute force way of doing undo would be to just nuke all data for all genomes and then just recalculate one at a time. But that could be kind of a pain for our end users who are trying to, they're expecting some data and then all of a sudden their predictions are poof. And that's because we decided there was a glitch or error in our signal transduction prediction or something like that.
Okay.
So, and it's a really big win. It's also helpful for developing because you can, write your thing, but oh, that didn't quite do it. I want to rerun it, and then just rerun that module. It'll clear it out and add the results with the new changes that you just wrote. So,
I have a question about this. I think it's connected to it.
what'd you say?
I have a concern that is actually connected to this,
Okay.
I think. One thing from the user perspective is since MIST is going to be easily to update, it's going to have constant updates, and it should. The point is we should be able to track what version of database we're dealing with.
So hopefully we don't have multiple versions of the database, and it's kind of like a living thing. So, the idea is that otherwise we have to kind of keep massive snapshots of the data out there, and that's pretty tenuous to kind of keep up with, right?
Can
So
we tag our data or make a database with versions?
So I'm not sure how the versions would work. Like, so do we want to say, well, in this version we have X number of genomes, and then if we just add genomes, is that a new version, or do we want to version it based out on tools modifications? Like, okay, we changed our algorithm, and so therefore it's a different set of results, or I guess those are the
Okay, so this is the concern, right? One of the things that I'm using MIST for, and I will in the future, is, for example, to produce as a data, right? So one of the things that my pipeline does is basically go there, grab the genomes that are relevant, bring back, like do a bunch of stuff with it, and fine, great. Problem here is my output is a config file, basically. There's a package software that basically takes all the important data that you need, back together with your config file, and then you're able to regenerate this data from scratch if you run the pipeline with that config file again.
Okay.
Now, the key point is to actually make it easy for people collaborating.
Mm-hmm.
So, for example, if somebody wants to actually take a look at my data right now, I'm not going to send them like 4 gigs of databases. I'm actually sending the config file. They can run my tool in their computer. It will generate the entire data set for them.
Sure.
Now, the other, this doesn't really matter what version Mist is, but the problem is this is every work in science is a work in progress. So as things keep going, if people start to actually using the same config files to actually regenerate the data, then you're going to have different data every time they run it because Mist is going to have constant updates. Also for auditing, right? So for example, I can also keep my entire data in my computer, or I can actually save my config file with a tag on the version of Mist that I used, and then somehow will actually, every time I run the algorithm, it will bring back just the genomes with the database that from that time. I guess that's the main issue.
Well,
also the database too.
So I don't know the right solution to your question right now, because I really, I mean, maybe it's, maybe we do versioning for parts of the database that, like signal transduction or something, where we can easily capture a snapshot and it's small enough that having multiple versions is easily referenceable. But as far as the actual genomes themselves and their representation, I view that as a pretty super stable that would hardly ever change. Now, I guess technically it could, like say we found a bug in the GenBank parser, and so we need to redo all the GenBank parsing of all the files. Kind of making the assumption that GenBank files that on NCBI servers don't change, although I think there's a possibility of that too. But assuming that's the case, then we would have to rerun everything, and there could be different things in our ultimate database, right? So do we keep 2 versions of that genome now? I'm hesitant. I really don't know if I want to go down that road, at least until we have more vision for it.
I think, well, I agree with you. I think it's just something to keep in mind, because this is one of the things was raised in the group meeting when I was presenting my tool. People actually were concerned about being able to audit the data 5 years later. It's like,
of course, when does that ever happen?
No, I mean, I know, but like, well, if you get audited ever, right? It's a nightmare, and that would be very helpful. Also, the idea is, if you decide to regenerate your data 3 months later, it's probably a wise idea, to be honest. But
it's a very great idea. I'm just trying to think of the.
One idea that I had would be, for example, if you have an extra table in the database with like some sort of tags that would work as a filter for the current database. So because you assume that the current database is always bigger than the previous one, that actually the current database contains the previous genomes, right?
It should, but again, it depends on how you modify the data with your algorithms or you store it, right? Like, so say you rename a column or you delete a column or something like that, right? Or say a rerun, like, okay, we're now upgrading our signal transduction prediction algorithm. Well, I'd really rather not have multiple versions of that hanging around. I'd rather just redo all the results so that there's one source of truth, one point of referencing that data. That saves it. It's easier to debug and work with, but maybe the history is a big enough issue that we'll have to deal with saving previous predictions. But so in that sense, it depends on what path you take, whether it might be bigger or it might be smaller. if obviously you preserve old records, that's one thing, but I don't know.
Yeah, so it's just something to keep in mind because it might be an issue.
Well, it certainly
Uh,
might be, and so I think yeah,
it's
let's
always gonna be an issue, right? Like databases and versions are always a problem. Everybody has to deal with that.
yeah, definitely, and I think thankfully we don't have to deal with it quite at this point. We can deal with it more towards the end of when we're making a recently okay our next upgrade with that. Okay, well, how do we handle this old data? Now we kind of got the main pipeline working, and
Yeah, I, I
good
th-
point.
yeah, I think at the end of the day, this is exactly what I'm gonna. If we don't do any versions on the database, which I think we should. Actually, now that I'm hard thinking about this, it's gonna be a whole lot more trouble than solution.
Yeah, it'll be
So
quite
you just,
difficult.
yeah, I would just recommend in my documentation that you keep like the files. It's like it's your job. So we're gonna download the data, everything, and if you actually work, it should be one way that actually we do. Okay, so this is easier. We should allow one way for me to figure out if what I'm dealing with right now is different than I dealt in the original config file. So it should have like a last update tag somewhere in one of the tables that shows when was the last update done. You see what I'm saying?
Oh, like modify the. I
So
see.
for example, I know if I rerun the config file, I'll have a warning. It's like this is gonna run again with the same conditions, but this is a different. There's a different version of genomes in MIST.
Mm-hmm.
Now you can actually go ahead and do it again, or you can ask. You can actually use your previous files that was already downloaded to actually work with the same data set,
Yeah, that's interesting.
right?
So,
I think that's an easier solution.
Davi,
Yeah.
why don't you configure your config file to just download like a flat file or something directly from the database?
It
So you
does.
have a snapshot, right?
It does that, yes.
So
So I do have a
why
snapshot of.
why do you want to get the same information again from MIST?
So the point is, for example, let's suppose I start working on something right now. So, and I'm working on my data, blah, 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 and then I find something very cool in 2 months from now, and then I want to send it to a collaborator. One of the ideas is, instead of me sending gigabytes of like flat files, I would just actually send my config file to my collaborator. It runs the pipeline there. We'll go to MIST and download all the data there. Then it can use any way they want. But the point that I'm saying is it would be nice to actually know if there was any update from MIST from the day I started to what I'm delivering, because they might not get exactly the same result as I'm having right now. You see? The idea is to have the same data in both.
That would be handled by your config script, right? The database can't.
Yeah, everything is done by my pipeline. So my pipeline will go there, use a bunch of instructions, and go get the data in MIST. So, but if MIST doesn't tell me that I have a different version of the database, I'll be completely blind downloading a bunch of data sets that I don't even know if they are exactly the same or not.
I don't know. I think the simple solution is you just send the 4 gigabit file to your collaborator.
Well, that is what I'm saying. But it would save a lot of time if you actually just put like one tag every time we actually do an automated upgrade of MIST or anything like that. It's like, hey, there's an upgrade compared to your previous version. Feel free to run again, but this is a warning, and we're probably gonna have a place on the website where we actually show what's being updated and when. So you can use that tag to actually.
So I think we've already got that kind of in place. So what the status of things will be able of a genome or whatnot will be able to be introspected from the database. So our pipeline consists of a series of independent modules, and when you pull down or fetch the genome record, we'll make it where it also reveals the state of all the modules that have been computed on it. and along with that, the timestamps of when it was created or when it was finished,
Exactly.
and so forth.
That
And
would
so you can easily just query those to ascertain whether you need to do something different or whatnot, or it matches what you're after. So that probably solves our problem, at least in a step in that right direction. If maybe not a full solution, but I think it'll be good.
Exactly. Yeah, no, this will solve my problem. My problem is like at least I need to. I I have no problem sending the 4 gig files to my collaborators. I would rather not, if I don't need to.
Yeah, and so yeah, that's totally legit, and so maybe that's the solution there. Whatever we can, our timestamps are the versioning of all this stuff, and since each module could be run pretty much independently, it will probably have to be done on a per genome kind of basis, but that should be fair. I mean, and our front end website for MIST will actually also have to be able to adapt to each of that. So like obviously we can't display signal transduction predictions for a given genome if they haven't been done. So it will have to look at that record and say, oh, okay, there's nothing there, so nothing to display, and alert the user somehow to note that, oh, we got the genome in, but we haven't finished computing it. So we'll be working through a lot of that logic too. So cool. Well, maybe that solves our problem, at least for now, and to give you a way forward. Cool. All right. So let's. So yeah, the independent modules is a big deal, and the redo undo is a big deal. I've been hounding Igor to try to get me the signal transduction rules. I will. I think probably soon start implementing that module, the signal transduction thing. I can't share that bloody. So let me see if I can do something here. I am going to Slack you guys a link, and I'm going to see if I can't work here. So can y'all see this? Click on that link, and then let me know if you can see the little mobile whiteboard I got going on.
Yeah. Wow.
Okay, so you can see this. Whoops, let me rotate this back here.
You know who can't see this?
Ogon.
Ogon won't be
Well,
able to see this.
I will fix that right quick by sharing my own screen here. So this is kind of a little bit of a hack here. Let me show
now I can see it.
So now you can see this. Yay. All right, so I have my own fancy little whiteboard thingy here, and
oh, you got this as a present for yourself? Is that
pretty much?
That's awesome.
A little business expense, and so now we can draw things like fun stuff. Woohoo!
Awesome.
I don't know how fast it is, but it looks pretty responsive. I can do some fun things and make fun marks.
Pretty cool.
All right, so enough of that. So what I am kind of want to show you guys, I want to draw out the different modules, and I have a pretty diagram for this elsewhere, but I don't have it here. So, whoops, that's too big. Let's get rid of that, shrink my font down here. So we have the seed genomes module, and then the NCBI core data module. So the seed genomes module, this guy basically allows us to stuff new genomes in the database. The core data actually populates the database with the full genome records and so forth. And then if we draw this as a dependency graph, we have this ASEQ compute module, which completely depends on NCBI core data. So under here we have, let me grab here, PFAM30, and then currently segs and coils. Up here. So these are kind of all related to ASEQ compute. Well, then the next module that we have kind of down here is the predicting the signal transduction proteins. And this guy, he depends on PFAM30, really. So signal transduction, this guy depends obviously on PFAM30. PFAM30 depends on having our actual genome in the database. And so now what else have we got going on here? And I want to hear what Davi's got on this. Is over here there's this other module called gene clusters, which he worked on recently. And so now we have another module over here which are called signal transduction systems. So this is like where we actually predict the two-component systems and so forth. And so that depends on the signal transduction proteins and the gene clusters. So you can see how we're starting to build kind of a dependency graph over here of how things work, and these are kind of all, the pipeline has all the logic for checking for these dependencies automatically built into it. So if you say, hey, I'm ready to run my signal transduction systems, it's automatically going to check that you've done your gene clusters, and then automatically check that you've done your NCBI core data, and so forth. And y'all see how kind of that's working here?
Yeah.
Yep.
So what's pretty stinking awesome about this is now we can start to really plug in our functional units of what we want to do. So for instance, another one that we have over here, and this is what Ogun is working on, is taxonomy. And that only depends on NCBI core data. And then I believe Amit is over here, and he's working on the transmembrane thing here. So we can plug these all in, and then off we go on our lovely way here. I haven't been able to give you guys a good demo of this because of just life in general, but I'd like to do that at some point, maybe today if we could. So I want to give you guys a demo of that. I want to talk about the error stuff with Davi, and kind of our next directions and so forth. Does this make sense? So briefly, what I talked about here.
Yeah.
Yes.
How cool is that? When I finished.
Oh yeah.
When I finished PFAM30, it was kind of like this is so stinking awesome because it's completely automated, and it's just beautiful, and I hope you guys will be able to see that here. So cool. So I've talked a bit. I want to kick off a demo for you guys, and then that may take some time while PFAM30 is running, and in which case we'll then kind of jump on to where you guys are at. Sound good?
Okay.
All right, so let me come back over here and see if I can share my entire screen without it flaking on me. And it doesn't look. Guys, let me know if it flakes out on y'all and starts doing the weird flicker thing that you guys have been dealing with. Dang it. Okay, so over here in Pipeline, and I'd really like you guys to be able to experiment and make sure it's working on your machine, so it's not just me here. But here I am on my whatever you call it, Visual Studio. Let's see. Got everything running, but I want to kind of get it from a clean slate for you guys. So I'm going to say Docker compose down.
Okay, I'm gonna do the same. Hold on. That's what you want, right?
Well.
Or you want us to actually do this later?
Maybe
Let's do later.
You can do it later, just so you can ask questions. It should be pretty straightforward, and so forth here.
Okay.
Now, if this is at some point, we're going to stop doing this Docker compose down stuff, and it will be more because technically you don't want to just always rebuild from scratch. That's kind of shouldn't have to do that. So, all right, Docker compose down. So I'm going to go scripts, remove danglers, just get rid of everything. All right. So I'm now going to say scripts launch. So now what this does is it does all our magic. You guys have seen this before. And it's waiting for Seek Depot, I guess, to come up here. Seek Depot is doing its thing. I was trying to figure out how I can get it to output this kind of messages to Docker Compose, but I wasn't able to figure that out before this meeting. So
Docker attach.
yeah, I got that wrong. All right, so we're in. Beautiful. So now I don't have my no modules here, so I'm just going to quickly install those puppies. Okay, so while this is going, I want to talk a little bit about how to run this thing. So there is a in the pipeline folder, you'll so I'm in this API pipeline. There's a pipeline.sh script, and that's what you use to run the pipeline. So you hit it, and it will spit out a bunch of the text. You guys have seen this before of how to actually run this. One change that I made, I don't know if I've talked about it with you guys yet, is that, and you know how there's once modules and then there's per genome modules? Previously you had to run the once modules by using -o. Now it doesn't matter. You just put whatever module you want out there, and it automatically sorts out which ones are the once modules and which ones are the per genome modules. So that's kind of a simpler interface pattern I kind of implemented. So less for everybody to think about. So you can see there's C new genomes, and then we have the PFAM30 in there as well as the NCBI core data. So
Dude, I probably should make it like a note and actually talk about this later, and then I will this time. But before I forget, we need to. I just reading this, like if no genome IDs are so specified, we should have like an easy way to translate our genome IDs to project ID from NCBI.
So this is a great point, and I will. Well, we'll just talk about it real quick right now. So what I really want to do is step away from using our internal IDs externally, period. This provides a lot more, because if we have some wonkiness happen, then we have to redo our IDs, then our users are screwed. So I'd really rather them not reference directly our internal IDs. That gives us the leverage or the freedom to do what we need to do. So let me jump back over to my my whiteboard here. So let's see if I can scroll up here. There we go. So let me jump over here. So so for instance, in our API for MIST might be something like genomes / and then we would have, dang it, doesn't do well with eyes. They're gonna screwed up on me again. ID. There we go. So that's kind of one way of doing it. And what I'm actually want this ID thing to be is it can be one of two things. It could actually be our internal ID, like 345. Dang, these stupid eyes, they kill me. See, I go to put a dot on the eye, and then it thinks I'm trying to select it. So this would be our internal ID, which I'm trying to kind of step away from. Or B, what I really want people to use is something like, this is not a real one, but it'll give you an idea of it, an accession. So that everybody uses accessions to reference their genes or proteins of interest, and therefore that never changes, regardless if we change our internal IDs.
That sounds good.
And so these accessions are associated with the. We have an accession for the genome. We have an accession for the component, and we also have an accession for genes. For
what is a component?
Well, component, yeah. Or did you ask what a component is?
Yeah, yeah.
These are like replicons or plasmids
Oh, okay,
or
okay.
contigs.
Yeah.
It's my generic word for any of those.
Okay.
Um, so it kind of covers all the above. So that's where how I envision kind of the identifiers go. And so and similarly, the routes, instead of being genomes for components, it'll be components ID, and then obviously genes ID.
Well, uh, if they all accessions and they are all unique, you can actually just have one route, and then the
So
user will know what they are asking.
so what do you mean one route? Because this is one route, right?
But there's three routes, right? Like one for component, one for gene.
Yeah, but what if you want to access the gene, but the gene is not a component?
Right, but then they have their own unique session number, right?
Correct.
So you just put the right accession number, you're gonna actually access the component, not the genes or the genomes. So you can actually just have one route.
Oh, yeah. Okay, I see what you're saying. You could certainly do that, but it's not as clear. I think usage all the same. So maybe to that thing, we might have a search
Yeah.
or something like that. That might be another way we would handle that, I think.
So I don't know. I probably should look it up. But like accession numbers, they have any logic to it? How
They do.
Okay. Okay.
This NC, I think, is like it stands for RefSeq or something, and I mean, I think this is more like a complete genome. There's NZ, which is I think for like draft contigs, or a lot of the GenBank ones you'll see start with something, a few other letters. So yeah, there is some logic there. I've largely just ignored it, but
Okay.
there is something to be said for that. I don't
No,
know what.
because for example, it would be cool if there, for example, the component is the genome session plus more information, or and then the genes are the genome, the component, and there's some more information on the tag for genes. But I don't know how actually a session works.
Oh, you mean I'm not sure I'm following.
For example, you have the NC1234.1, right?
Yeah.
So that would be the genome, let's say. And it would be cool if actually the components goes for NC1234.1.1 or .2 for each one of the components, and then another dot, and then you have all the genes from each one of the components. But I don't think that's how it works.
Yeah, I don't think so either. It might, but I seriously doubt it because I think they can get added or in any order, and it's not necessarily sequential like that.
Yeah, that's the other point, right? Like because they're not sequential for genes, like you need more information. But it would be so cool if they would have like information if the genes are in sequence or not, or like the gene neighborhood, for example, would be already in the tag, but it's not. I don't think so.
Yeah. Well, so let's jump back, but that's kind of how I would envision the genome IDs, kind of being handled in a stable way. Is that we look at those accessions, and actually, I think we might as well support both ways, right? Give the internal IDs as well, which our website will probably use, but as well as support, doing the accessions. So, but just with the caveat that the internal IDs, that's kind of dynamic, and it may or they aren't stable. You can't really trust them. So that's kind of my thinking on that.
Yeah. No. Yeah. Exactly. Yeah. No. It's important to actually have one identifier so we can actually go back. So because the point is we can actually we put this in a publication.
Yep.
Right.
And so by using accession numbers, we kind of solve two birds with one stone. We don't have to come up with a stable ID ourselves, and we provide that. We leverage accession numbers and identifiers people are already familiar with or have used elsewhere. So it's kind of a double win, I believe.
Yeah, I agree.
So over here, though, with the genome IDs, this is actually not accessions. This is expecting internal IDs, because typically we won't need to. I can see where it might be useful to use an accession, but it's really more just for isolating to a particular genome the effects of one thing or another, and at this point it's mostly for development purposes. Oh, I got 20 genomes, but I only want to test my module on one of them, and it allows you to scope it that way. But ultimately, we probably do want to have that ability to also use accessions there too. Okay, so redoing a module, this is kind of an important concept. So there's undo and there's redo. What's the difference? Well, undo basically. How do I do this? I got to refresh my memory. This doesn't do it across all genomes. It's kind of more immediate. So in other words, if you have modules that you want to undo, it will undo them, and then after it's done all the undones, it will actually do it right then. But if you Control C or break out of it, then the rest of the genomes that it didn't get to it won't be done whatsoever. Redo, on the other hand, kind of is more to capture this, that you want to redo all of the modules regardless if another worker comes on board. Because remember, this is a parallel kind of a system we've built here. We can have multiple workers running in their own little pipelines independently, and so redo kind of enables other workers to jump on the bandwagon per se. So if you'll notice in the let me just show you here. Oh, I haven't run my thing here, so let's just cheat then. We'll do it a different way. The DB migrations genome. So if you look in the workers modules table, you'll notice there's a redo flag. And so what this is for is if we redo a module, what will happen is it will actually go and set all modules, all records that have been done, or all genomes that have had that module already done, it'll set that to true. So therefore, even if it dies and another worker starts, it'll say, oh, we still need to redo this. The previous worker didn't finish it. And so that's kind of the notion of redo. It captures that state regardless of where you're at. Undo, it doesn't capture that. It just kind of undoes it and then runs it right again in that same thing. Does that make sense, sort of?
Yeah, sort of.
Sort of. Maybe I need to use my whiteboard again. All right. This is not super important to understand right now, but I'll try to clarify it again. So we have, say, 3 genomes in the database: genome 1, genome 2, and genome 3. And let's say, the modules that we have available. This genome 1 has done signal transduction predictions, and this guy's done signal transduction predictions, and this guy hasn't done it. Okay, so now let's say we have a worker that we kick off, and we say redo signal transduction predictions. What this worker is going to do is he's going to go set up and say, oh, this guy needs to be redone, and this guy needs to be redone. And then, so that's the first thing he does. And the second thing he does is he starts working on genome 1. So now he's obviously working on this guy, but suppose he dies for whatever reason. Our server dies or whatever. Well, now what happens is this genome 2 is still, because of the database state, because of that redo flag, we know that we still need to redo those so that when a new worker pops up, well, that's hard to see.
I see. So we'll pick it up what is in the pipeline for redo.
There you go. Exactly. So when worker 2 comes on, he can say, oh, this guy needs to be redone, and so does this guy, and he can pick up where they left off. And so that's that redo flag. And in fact, worker 1 can set everybody to redo.
So it's not a redo, it's like a continue, basically.
No, it's a redo because what happens is as part of the redo process, let me grab a marker here. As part of this redo process, what does it do? It first does an undo and then it runs it like normal. So by undo, we actually are deleting data, and then run puts the data back in. You see?
Well, but you have to undo because you didn't complete, right?
Well, so remember at the beginning state here, let me grab my marker. At the initial state, the signal transduction prediction is already done, right? And so this worker, when he comes in and says redo, he has to nix, those results and then redo them.
Right. But just because it's incomplete.
No, it was complete, right? Say this signal transduction version, say this is signal transduction prediction version 1. Now we got signal transduction version 2 on the way. If one's complete, we just have to, get rid of it first. That's where this what do you call it? This undo
I see.
doesn't play.
I see.
And then so that's why.
So that's why you actually keep talking about the idea that we won't have redundant. We don't have like our older versions, because you're gonna literally delete the data first and then back it up with the new one.
Yep.
Isn't it better for just the purpose of having something online to actually do first and then delete the data later?
So then you're exactly right. And so what happens is, so yes, and so that's why we, let me grab this thing here. That's why we first off, we only do it on a genome at a time. So like, right, we work on genome 1, and we undo it, and then genome 2 still has genome 2, I'm trying to master my tools here. This guy is still at version 1. And so, yes, at any given point, a genome may not have data, but due to the pipeline logic and making it easier to use, we actually we do have. There's a temporary space and time where it can be. There's no data for that module. So yeah, I guess this optimization would be to try to make it where we just grab all the data and then we undo it and then we add the new data in there.
Yeah, you have to first finish, then you actually do the undo.
Mm-hmm.
Because otherwise, we actually have the risk to have an empty database.
Well, not empty database, empty module.
Empty module, yeah, that's what I mean.
And
so
that's why
parts of the website won't be giving results because something happened.
Yeah. Yep. Well, and that's just something I think we have to put up with, and I kind of expect that can y'all see my mouse, by the way?
Yeah.
Okay, that makes my life a little easier. So that's why you'll take this introspect this worker modules table to see what state your modules are in and what's been done or whatever, because it'll tell you whether you're redoing or something. I think another state is in here is undo. That's kind of the idea, and these aren't going to change that much. I mean, it's going to be more or less stable most 99% of the time. So until that's a bigger problem, I don't want to try to do too much logic, but we certainly could do that. That's it. That's actually a good point. I don't know. Maybe I'll think about seeing how easy it is to put that in. See, part of the complication here is if I take my So remember, going back to this graph, well, why is it not showing in my graph? Do I need to click somewhere to get it to pop up? Oh, I get to scroll it myself. Oh, I get to scroll it myself. There we go. Okay, so as you can see on this graph, it undo is kind of a complicated thing. Like, suppose we choose to come on now. Suppose we choose to undo PFAM30, but we already have signal transduction proteins predicted.
Right.
Well, that's the problem, right? We can't undo that guy until we first undone signal transaction proteins. So undo and redo has to be smart with respect to this dependency graph that is present. Um, and so that makes things a little trickier when you're undoing stuff. And so I actually have logic built in that will look at this dependency graph and look at what you're trying to undo. And if you're trying to undo something that has a unmet dependency or something depends on it, it rejects it. It says you can't do it. Sorry. You have to also undo signal transaction proteins to be able to undo this.
Right, because so so the problem you're resolving by actually creating a lot of logical problems here is actually you have one snapshot that are all coherent throughout the database. So our signal transaction systems are always up to date to our latest PFM definitions.
It should be, yes.
So the point is like to always have the entire database consistent. So if you actually, right now you could only update PFM 30 to, I don't know, 31, and then you still have the signal transaction and the other signal transaction systems in like based on PFM 30.
Mm-hmm.
But you don't want to do that. You want to have the entire database completely coherent.
But it will probably be progressive on a per genome level. So that's kind of goes back to the redo thing. So for instance, when we get the PFAM 31 in here, and then we will have a new version of the signal transduction proteins, and all this entire dependency is per genome, except for these C genomes. So we might have one genome that's still based on with predictions based on PFAM 30, but other genomes based on PFAM 31.
But temporary, right?
What?
Temporarily.
Absolutely, only temporarily. Yep.
Yeah. So during the update, basically.
During the updates, yep. It shouldn't be, back and forth.
Yeah. No, but that's transient is okay. We just need to actually tell the user that it's happening. Like there should be a tag on the website like this is being updated. We're in the current updating the database and doing this or that, so people will know.
Yeah, that's a great point though. How would we show say something with like signal transaction proteins? What version per se it's on?
Yeah. I think that's a major thing for the scientists, right? Like imagine that I find something really cool, I'm super happy, I'm gonna show my boss, and the next thing I know, it's not there anymore.
Yeah, that's the problem. I have to do some thinking about that, but I don't see that being too tricky.
We could probably, like for this purpose, we can actually have that might be not ideal, but we can have like a snapshot for the public, and then we do the automated things on the development side of things, and then once all the results are done, we substitute the database at once. Oh, not the database, all the routes. And you know what I mean?
Mm-hmm, I do. I exactly do.
I think that might be a little less disruptive for the user.
And that's actually what I did with Seek Depot, but it just means now we have two massive databases, which it's just, you need big machines to run efficiently and so forth, and then do the switch over like that. Right. But it's definitely the least disruptive way of doing it.
Well, how long it takes our updates? You think how long is it going to take more?
It'll probably take. It depends on what we're updating. If it's just something simple like single transaction proteins or any of those, that's not going to be too long. You could probably do that in a weekend, easy.
Yeah, right. So I imagine that actually we should just actually put a flashing tag like, "Watch out, we are updating."
Hang tight. Yeah, we could expose that. Another thing might be a good way of doing it is we just have another module, signal transaction version 2, and then we retire the previous one once everybody's migrated over.
Yeah.
And then by looking at the worker modules, table, people can easily ascertain what's going on. But still, having a kind of a major update like that would also be useful. Very good thoughts.
Yeah.
Okay.
The point that we need to always praise consistent. So this is a very important issue.
Need to always what?
We need to praise consistency. So we need to be able to actually the information we're going to provide need to be consistent somehow. It can be like, I really like the idea that Mist will be like a living organism, basically. They would just update itself. That would be awesome, right? It runs another PFM, launch something else, Mist already knows, go there, pick it up, and actually do all this stuff, run all these pipelines. That would be great. But for the user perspective, that might be a nightmare because you always have like a mutant version of information. Now, although we probably should encourage our users to download the data that they need to work.
Yeah,
so we should actually make this part of the documentation. It's like, it might be a living organism, so we recommend you to download the data you're going to use for your project and work with that.
Maybe the strategy is more one of just having strategic maintenance periods, and as opposed to just updating it willy-nilly whenever we feel like it, and that way people can kind of plan accordingly for that.
Because we can't.
Obviously, adding data is not a big deal. It's really just more mutating data that becomes a problem.
Right. So exactly. So I think the big thing right now is exactly that. Like, we can resolve this problem by scheduling maintenance.
Correct. So,
we're gonna do this day. Watch out. We open a Twitter account for Mist and then just push it out.
Yeah, that's actually a great idea. Twitter. Definitely a good idea there. Okay, so very awesome points. I really am glad bringing this all up.
Sorry, I'm doing all this sidetracking because I think like now that I'm back into the project, I'm having all these thoughts and I think I need to actually put them out there. It might not be the right timing,
but it's okay. These are I mean, you've already given me a lot of good food for thought with say especially the signal transduction stuff and versioning. So that's super helpful for sure. Okay. So let me jump back over here and see if we're all done here. I think that's in place now. What was I going to show you? Oh, I guess I was going to show you the pipeline, I suppose. All right, so I should be able to run the pipeline. So let's just try to run this pipeline. So if I say pipeline, seed new genomes, and then NCBI core data, and then AC compute PFM30 plus segs plus coils. Now this lovely command should it'll run them in, and actually it's pretty neat. Like I can even put these out of order, and it'll figure out what's going on. So I can say NCBI core data and seed new genomes, and it'll still get it right because it's going to build that dependency graph, and then based on this dependency graph that's programmed, it will rearrange the ones that you've specified into making sure they can be run in the right order. And if you try to run one without the corresponding dependencies met, it'll just skip it. So it kind of takes the brain having to think about, well, what order needs to be run when? It takes that out of that. I spent a long, bloody time coding that all up. But anyways, you guys are welcome. So okay, here we go. It's rocking and rolling. I'm going to scroll up because it went really quick here. Come on. Where's my? Do I have a scroller? There's no scroll bar on this. This is pretty swine.
Dude, I got a mouse that actually you can scroll with like a freewheeling. It's a free wheel, so you can just if there's a button to toggle that, you can also do the little ticks like you're doing right now. You can hear from here, but you can actually click and then we'll just free wheel. So it's completely free. So you just rotate and gain some momentum and just keep rotating. It's great.
No. Dang, that would be super handy.
Yeah, right now especially. Yeah.
Can you
Yeah.
send that via email to me real quick? Okay, so I can unfortunately not. It's actually not allowing me to scroll, which is a really swine here. But basically, this is a bunch of log messages, and the first thing it did is it went through and downloaded the genomes, put them in the genomes table, and then it parses the components one by one. So here loads the component, and then puts one gene in. This is this is I think a draft genome, so it's only 347 bases long. But if you look up, and they're ordered in, I think the way RefSeq orders them is that the largest components are first.
Yeah, it's an IKEA.
Yeah. So, anyways, that's kind of hard to see here.
It's interesting name, right? I don't understand why. But okay, go for it. Sorry.
So it loads all this lovely stuff in, analyzes the tables for statistics afterwards, and then so you can see the module NCBI core data finished. Now we're starting the module ASIC compute. It says, hey, you got 2,467 ASICs that need to do at least one of these. And then off it goes. It starts computing them, and if you could hear my computer, you would hear it humming in the background. But if we jump over to our database here, pardon me, you'll see that let me get from genomes. Rid of that. Let's do this a little better. Having typing issues. So you can see that
so cool.
It's got a worker associated with it on this first one, DSM 637. And for instance, we could say select star from workers. Should only be the one. Here, let me say. So this is my one worker ID 1. Here's my IP address. And this is the job we're running. We see new genomes per genome. We're doing these and so forth. This is when we created it and created that and updated that. So if I say select star from workers modules where worker ID equals 1, here it's done the module seed new genomes and it's finished. That's why it says done. This is when it started and it's finished. So we can look at those to see when they're done. Then it did the core data module. It's finished. And you can see now it's working on PFAM30 and it's active. And then the other modules, it's actually doing coils too. I didn't think it ran all three at the same time.
So once we actually
oh yeah, that's right.
Once we finish this ASEC, we're going to store them as SecDepot.
Yep, it's actually exactly. It's stored at the ASIC depot. So if we go to set search path to public SIG depot, you can see we have basically 3 tables in the SIG depot schema, ASICs being the most important one, and then and so this data that is being cranked is actually will be stuffed in the ASICs table.
Okay, so it does check if that ASEC that comes from NCBI was already in SecDepot or not, right?
Yep.
Okay. And then checks.
Wait, say that again. It checks if it was what?
So, for example, you're downloading the genome, right? You just got a new genome.
Yeah.
So right now, you actually have all the sequences. So now you're calculating all these computations that needs to be done, but it needs to be done because you already checked that they're not in the SecDepot, right? Already.
Oh, you mean in the existing SIG depot?
Yeah.
No, this is all it's all in the local SIG depot. And
no,
local
but eventually the local is going to be actually even bigger than the previous one, right?
Correct. You mean for the next genome?
Yeah. No, I mean for the entire MIST. Once we actually have MIST up, the local SecDepot for MIST was already complete with the entire all the genomes, right? Sorry, let me try to rephrase this. So you're gonna have like a local SecDepot running for MIST. That's what it is, right?
Yes.
So before you actually, once you download the genome, you check if each sequence is already there and already computed the information that you want to.
Correct.
Okay, that's all I know. And then
it doesn't redo the data if it's already computed. Maybe that's what you're asking.
Okay, yeah, and then we're gonna serve SecDepot from Mist.
Well, sort of. SeqDepot will still exist actually as a separate entity, but there will be basically the SeqDepot is gonna. There also will be a SeqDepot under the Mist umbrella that it works with directly.
Yeah, yeah. So we're not gonna have, even though we're gonna probably serve its own API, but the data is the same, right? Like
correct. Yes, it'll be the same
database.
Yep.
Okay. Yeah, you're not gonna have like a separate computer like we have right now, right?
Well, yeah, we will for the main SeqDepot because we still want to have the SeqDepot independent of Mist, and so what we'll probably do is daisy chain them here. Let me just go back to my drawing board.
Oh, and why we want that again?
Because some people may not, there's proteins that exist outside of Mist that people might want.
Oh.
Right, so I mean, eukaryotes or whatnot. So,
but then isn't it easier for me to actually just look it up the information on SecDepot then?
It will. So here, hang on one second. Okay, let me draw another lovely line here. Wow. Why is my thing not working? There we go. Okay, so back on the drawing board here. So we have two lovely entities over here. We have SeqDepot, and that will exist all by its lovely self. And we also have Mist. All right. So now Mist is going to basically take a bunch of the code over here. So we'll have a bunch of code, and we're basically borrowing that over here, and then housing inside Mist its own SeqDepot stuff, and its genomes and all the other fun stuff. So that we basically don't have to depend on SeqDepot to stay alive. It will use the same code as SeqDepot. It will use the same database structure as SeqDepot, maybe even some of the same routing, but it's stored completely in this database. And so, yeah, it's a little redundant. That's fine. But the idea is now we can build out Mist without having to worry about SeqDepot being up. Because what happens if SeqDepot crashes? Well, that's another dependency we have to manage. So this kind of insulates us from that as well as keeps it relevant. But SeqDepot is not a superset of Mist, or it is a superset of Mist. Mist is not a superset of SeqDepot. So things like eukaryotes and all this other stuff, we'll stuff that all in there, or even genomes we never want to see in Mist. And this is kind of the distributed notion of SeqDepot. So what will happen is when we get a new genome, say in here, we will try to hit our SeqDepot for new sequences and new computations as well. So say they're trying to run PFAM30, we'll see if it's local. If it's not, we'll check in the upstream SeqDepot, and then we may pull it down back locally as opposed to calculating. But it will.
So we're gonna avoid the calculations that actually SecDepot has done. So we're gonna populate our own SecDepot. We're gonna check if you can populate our own SecDepot with the main SecDepot.
Yes. Yep. And so, for instance, if we want to actually run PFAM30, we could even run it here and then push the results to the upstream SeqDepot. So it's think of it as it's distributed, right?
Well, that's not a good idea, right? Because like SecDepot is a superset.
Yeah, but SeqDepot may have never seen a sequence before. It should be, but it may not have, right?
Oh, I see. It's just more, right?
It's just
Yeah, sure.
So that's all logic that has yet to be completely fleshed out, but I think it's a lot more useful because you could also entertain notions where people will, I want my own local SeqDepot, but I don't want all 6 gazillion sequences that exist in the protein universe. Well, now they can set up their own system for doing that very easily just by using a local copy of SeqDepot and then pointing their whatever resource they're trying to build at that. and now they can have, even if it's only 2,000 proteins, that can be very useful, and to have all that logic in one place, but obviously without the burden of a gazillion proteins and everything else under the sun. So that's the idea of having a distributed seq depot. Is now you can have on-site subsets that carry all the seq depot functionality without all the overhead.
Yeah, I suppose that actually this path from the missed seq depot to the main seq depot will probably never happen. Because I would suggest for us to actually do our updates in sequence. So you update seq depot first, and then we update missed, since we're gonna do schedule maintenance. Right, yep. So normally all the data that you're going to actually do in missed is going to already be already computed in seq depot.
It should, and I mean it can, but I could see with
not the signal transduction approach.
Yeah, of course, yeah, that'll obviously be a miss, but I could see that getting out of sync with people getting busy and other stuff, and so it'll be nice to have that just all teased out separate, where again you can you can have the master seq depot up here. And then you could have basically this tree structure of other seq depots that each seq depot has kind of an upstream a node that it can talk to. So basically this guy right here, he would look first here, and if this guy doesn't have it, he may look here, and then you can imagine that path traipsing back down. Down to here and then back to there, right? It's distributed in that sense. So
no, makes sense.
That's kind of that's the vision for it. That's actually a good bit of work to be done for that. So rather than having to wait on that to get missed going, I've just kind of gone ahead and done a lot of that coding inside the missed repository, but we'll probably end up having to break it out into its own separate project. But whether we write it in missed first or seq depot first doesn't really matter, just as long as it's written and it works. Cool. Questions?
No.
All right. So this is this. The seq depot, ASICs are all in there, and if we look at the worker modules, I don't know. Let's see if it's done yet. So it's still working on PFAM30, and you'll notice if I say select count star from a. So remember, it's in the seq depot schema. Now I'm just saying, give me all the ASICs that don't have PFAM or that have PFAM30 in them, and it looks like they're all done, which is interesting. Oh, there we go. I just finished. See, look, here we just loaded another genome, and I don't know if you saw that, but it popped in about 1,700. So 1,792 genes were thrown in there. 1,710 of those actually were coding sequences. And then here's the the cross references, the component features, and guess what we're doing now? We're back to computing PFAM for that one. So if we look back at this, you can see now that PFAM30, segs, and coils is all done for genome ID of 2. It's also done for genome ID of 1, and now it's working on genome ID of 3. And so, like here, let's just say select PFAM30 and segs and coils from a seq depot to iSeq where we'll just say give us 2 of them. And so there we go. So this is PFAM30. And let's just give our IDs in there. So for this ID,
right.
So for that sequence, here's your PFAM30 data, and then there's your segs and there's your coils, and it's all run automatically out the gate. It's beautiful. And the other genomes that are being loaded in, if they have an exactly identical sequence to this, they're obviously not going to bother running it. It's just not. They automatically detect that. So, how stinking cool is that?
Yeah, that is super cool, dude.
And I think it's we have 6,400 in there right now, and how many? So 4,700 of them have PFAM domains already predicted for it, or whatever. So that's pretty cool. And of course, we have stuff. So the main structure, if you remember, is genomes. One genome has many components. Each component has many genes. And if we look at the gene structure table, you can just see all sorts of lovely stuff in here. And if it's, for instance, if it's a coding sequence, it will have a non-null ASEQ ID. So, like we can say select component ID count star as num genes, and then count ASEQ ID as coding genes from genes where component ID equals 1. Group by component ID, and so you can see there now, look, there's 520 that have an ASEQ and 534 total. So other cool things that we have in here is, so we take all the features of the GenBank record and we actually load them in here so we don't lose them. And if two genes, well, I'll get to that in a second. So for instance, we also have RNAs in here, so we can say select star from genes where cognate key equals tRNA, and let's just say limit to. So here you can see that for this ID, here's his tRNA for that guy.
That's awesome.
And I guess he doesn't have any other. I captured the codon, anti-codon in there, like the cognate qualifiers and so forth. Maybe he doesn't have it for this. And rRNAs are obviously in there. So these are, and then the other thing that's kind of noteworthy is components features is kind of the catch-all for everything else not in the genes table. So select star from components features. So here you can see like the source or the repeat region. Mostly repeat regions, I think, are what we capture. Key count star from components features by key. Oh, that's interesting. So look at this. Why did we get a CDS in there? That's very strange. So
Is it CDS?
What?
What is CDS again?
Yeah, for CDS. So, because usually a CDS always is paired with a gene of the same exact location, and I'm guessing it's because of its less than, right? We have an indeterminate start, and so therefore we don't have a corresponding gene for that. But let's see, it's 1070. Let's just see what select star from genes where ID equals 1070. Yeah, see, he has no ASEQ ID because he couldn't predict the actual
The gene.
The gene, and that's why it's marked as a pseudogene, I guess. Interesting.
Very cool. This is amazing.
So we have a lot of lovely data coming in here, and now what's cool. Also, another thing I want to point out, and this is kind of going over the top, but I'll show it real quick, is if we go back to the PFAM 30 stuff. You notice how we store the PFAM as basically an array of arrays?
Yeah, I hate that.
You hate that, right? Well, what's really cool, see, this is a lot more compact, so that's why we do it there. But if I actually show you...
My only problem is actually, if I want to search a certain combination of arrays, my query is, in Mongo at least, was ginormous. And it takes forever.
So we may have to think about that for a little bit.
I think we should just do like an extra table. It will be easier to deal with.
So we could make a materialized view or something one-off table for stuff. That's not hard. But what I was showing you is actually the way we work with it in the data. It's a lot. It comes back as we unpack it into basically the object form. So, for instance, here I'm looking at the ASEQ model that we have defined. And so for PFAM30, we have some special methods called get and set. So if you set domains, it expects it to come by as an array. And so then we basically convert it into an array of values, right? So name is the first one. That's what you see down here.
Right.
Store is the second one. But when you get it, we actually then convert it back into an object for you. So in our application code, we'll actually never have to use the arrays. We can always use the lovely, friendly objects.
Right. The problem is actually when I'm trying to, that's what I already said. The problem is like if I'm trying to just select certain proteins from the database that has certain, right, like sequence of, yeah.
That's
basically what Aquarium does. And we're going to do it for signal transduction, for chemotaxis. That's how we're going to actually get our KBs, right? We're going to tell we want something that has the methyl KB methylesterase domain. But we're going to have all the rules for bringing the chemotaxis proteins to the table. We're going to be based on this search right there, searching domain architecture.
Correct.
It'd be easier to actually.
So if you interact directly with the database, then you have to, you have some wonkiness you have to fight.
Yeah.
And that's a pain. So we may optimize that, and there's a bunch of different ways. For storage purposes, this is definitely the most compact because you don't have all these names taking up space.
Right. One thing that we can do is, I don't know. Maybe what we can do instead of doing arrays of arrays is just actually do a single, just one array, and then we just know all the information that should be aware. Then it's easier to actually search, right? So and orders and everything. The problem is that array in array, you have to do a lot of like in.
Oh yeah. So we can totally handle
just
all
flat that thing.
What you actually want to look at is, oops, that was not what I wanted to do. So if you say PostgreSQL materialized views, or not even materialized, it doesn't even have to be materialized, but you can just use a view that remorphs the data into, I guess this doesn't show you what I was hoping to show. Basically, a view obviously can morph the data into a different looking structure that is easier to query, and materialized view basically takes a snapshot and persists that view state so that it's quicker for searching purposes and all that jazz.
That's awesome. Okay.
Cool. So we can do tricks like this to kind of get around and optimize the querying.
Great.
And so forth.
Yeah, because it's I don't know if anybody else does that, but this is a really cool way that you guys decided to use to select proteins by using domain architecture as definition, and I'm actually, my thing basically generalizes, my pipeline generalizes the search for anything, not just signal transduction, and that's the basis of Aquarium, which is Ogunsto. So if this database, if we put some way this data very easily to search, then Ogunsto can actually drop the entire server side, and just skip the visualization part of it, and then bind to Mist straight up.
Then you don't have it's one less dependent. Yeah, that's beautiful. And see, that's the thing is what with our API, we get to control how it's exposed via the routes and so forth. So it doesn't, users don't even have to know about this. They shouldn't have to bother with this directly.
Yep. Exactly.
We can make it whatever form we want to show them, and so that's kind of what's going on there. Man, okay, you're getting me excited now because you're getting all excited.
Yeah.
So we're on the last genome here, ID of 5, and when that probably finishes, I say we do 5 at a time right now for testing purposes. It will show you some cool stuff. So each one of these is actually stored in the ID module state.
Look.
Yes.
Just one thing is we probably shouldn't make these meetings longer than an hour and a half. I think.
I absolutely agree.
Which probably should be like the next couple of minutes should wrap up. Just because it's gonna be hard for Ogun to watch this.
Yep. Okay, so, well, that's a great point. We need to move on. There are a couple things that are super important we got to talk about. What do you guys feel about having a daily meeting and what I mean by daily meeting, I mean something that's 10 minutes or shorter, and follows the Scrum methodology, and basically we say, what did you do yesterday? What are you going to do today? And what are your impediments? And we try to solve those. It's not a full-blown meeting like this, but I would really like to start doing that because I think it'd give us a lot of traction and focus that I feel like we've been haven't had up to this point. So, would you guys be able to do that?
Sure.
I like the confidence that Amit just exposed there in this answer.
Tommy goes silent.
Yeah. The problem is there will be many days that I won't be working.
So
until next week. I have a conference, then after the conference I'll try to actually put like 30 minutes into me. But like the problem is this, look, I'm not in a position yet that I can just sit down for 30 minutes and produce a piece of code. It's
Sure.
not in JavaScript. It takes me like blocks of 4 hours to work on this.
So well maybe what if people if people can't do it, they can't do it, that's fine. But I think it's something at least I will probably start doing, and if other people could do it, I think that would be great too. Just to kind of, and then we can keep a log of saying this is what Luke did yesterday, and this is what he's doing today, and then this is what Amit's doing, blah blah blah. Or and as people can do it, they do it. But I think that just provides continuity, as opposed to having to wait for if like there's a problem, having to wait for the next group meeting to kind of discuss it.
Right.
Then
I like that.
you see what I'm saying?
Yeah.
It's a touch point where we can say, okay, this person's dealing with this issue, and I could and it's not the place to solve them, but it raises the issues and gives everybody a sense of where everybody's at, and then I can work with them online or whatnot to try to get them moving again.
Yeah, so, I agree. I think that's a good idea. I just don't. I would be willing to try because my experience that actually these things falls apart. But I'm really into making this work.
Well, it will. Yeah, I mean, if you can't, like your situation, you can't do it, and Amit, you may not be able to either, depending on your schedule. Everybody's got unique situations. In a company setting where you have the same team working on the one project and that's it.
Yeah.
It's very effective. That's I understand it's a little bit maybe of a stretch here, but I'd like to get something of that nature going because. I feel like in some ways we're slipping a lot of the time, and I'm trying to best figure out how best to integrate you guys and keep going. And I think this module system is a big step there, but also I fear that there's a lot of impediments to you guys, and I don't find out about them until the end of every Friday, and then we all go on vacation for the weekend, and it's just we forget about it or whatnot. So. I'm just trying to.
The last vacation that I had in the weekend.
Well, I meant mental vacation.
Right. I don't have that.
Oh well.
But all right. No. I'm with you. Yeah. So we should do it. I agree with this.
So we don't. Yeah. We can try to start this. Why don't you finish your stuff and I'll think through structure. We also need to find out a time, and I want everybody to kind of, even if you can't do anything that day, it'd probably still be good if everybody could jump on for a phone conversation. And I mean, like
you can always I will have many questions when I'm coding that actually I don't get to actually ask, and I just know afterwards. A lot of these questions probably would be already answered in these 10 minutes meetings prior to even I have them.
Could be very well, yeah, very likely.
Yeah, this is actually really. I was skeptical at first, but I really like the idea. It's growing on me already.
Well, I think it's proven effective in other settings, so I'm sure it works. It's just a matter of making sure as a team we all commit to it. And maybe the trickier thing will be finding a time that works for everybody. But I'm flexible and so forth. And it has to be short. This meeting cannot go long. In fact, we'll have set a timer and we stop. Preferably under 10 minutes or preferably 5 minutes or less.
Cool.
So, guys, why don't you? Well, let's just while we get you on the phone. What's times that work for you guys? Well, I'll tell you where mine is, and y'all can kind of fill in. I have a 9:30 to another stand-up.
Should
9:30
we
to
do a doodle on this?
What?
We can do a doodle.
Sure.
Would be maybe because Ogun is not here, so we're gonna actually put all this timing, and then Ogun might actually video all of them.
Okay, so let's do that. Can you orchestrate the doodle since you're
I'll do the doodle.
the doodle master right now?
Right now. Yep. Got this. I've never done a doodle. That'll be my first one.
Oh, I haven't either.
But yeah, I know what it is. You do it too, right?
Yeah, I've seen it. I think I've seen it once before. I don't remember offhand. So, okay, you get a doodle, and let's get a time set up, and we can roll with that. We didn't get to talk about your errors, so why don't you just hop on the code channel or something, and we can chat more, and that way other people can benefit.
Yeah.
And then, I guess, yeah, I dominate all the time, so I apologize for that. Next week, we'll make sure everybody else gets a voice in here. I do want to give you, Amit, you got anything real quick? I do want to give you an opportunity to share.
I did something on Phobius thing. I already pushed it on I made a new branch, install TM. If you get a chance, can you please look at it?
Yeah, what branch is it?
Install TM.
Okay, F install TM. Okay, I will take a peek at that and see what I see. Where did you get to with that?
Well, I modified the gulp file and I wrote the README for where the Phobius script has to be copied, and I wrote like a test thing. But I'm not sure if that's exactly what we're looking for. So I've done something, but I think maybe it's better you take a look at it.
That sounds like it's well along the way. That's great. Okay, I will try to take a peek at that either. Maybe it's just this afternoon. If that's cool with you.
Yeah.
Great. Great work. So, and the last thing I want to send this off with is this thing finished, and if you run it and it's already done, it just doesn't do it. So it sees that those things are already finished, those modules, and totally says, nope, nothing to do. Bye. So that's pretty cool.
Very cool. Hey, the doodle thing, I'm gonna put this down. I'm gonna use Slack for this. The doodle didn't work.
Okay.
It's too complicated for what we need. So
That's
I'm
cool.
gonna do Slack.
Yeah. Perfect. All right then. Anything other urgent that we should cover real quick?
Now I want to go ahead, Amit.
Sorry. So Luke, have you decided on like the kind of machine that we need for Mist, or?
Yeah, no. I just know it needs to have lots of RAM and a good hard, SSDs.
So hopefully I will actually keep my machine when I get out. My machine has 128 gigs of RAM. And
I like it.
Has like a terabyte of like SSD cards, and it can serve me, no problem.
So because the thing is, Dr. Zulin said that we have some funds for buying a machine right now, and we also are moving some stuff around, like the servers. So when we are moving the other stuff, it might be a good idea to also have the Mist machine in that location.
Yeah, no doubt. Okay, so that's been on my radar, and I haven't knocked it out yet. So I need to spec that machine out. One of the impediments I've been running into is Dell seems to have kind of pretty high prices for what I was looking for, and building it ourselves is actually a lot cheaper. But there's a little complications in that. Obviously, somebody's got to build it, but I don't want it to be here. I want it to be at UT, so I'm not sure I can build it because otherwise we'd have to ship it. So I don't know. I'm trying to figure that junk out.
Okay.
But I will not see what I can do about knocking that task out this week because it's obviously a time issue, and we're on the cusp of deploying our code to actually where we have iterations of deployment, and we obviously need a machine for that. So as a step in that direction, though, I'll probably pay for some cheap databases out there that we can just start to experiment and toy with. And this will serve as kind of our test, staging and development environments. But yeah, we need to get that. What?
We're gonna do Heroku?
Temporarily, yeah. It's so point and click, and I'll probably pay $14 a month or something for a couple databases. But I don't know if we'll stay on Heroku long term, but it's easy to get going. and I've had experience with it. So,
Yeah, Google. Yeah. Okay.
cool. Thanks for bringing that bringing that up on it. That was helpful. And I'll knock that out this week.
Okay, cool. Thanks.
Yep. All right. Well, thanks for hanging out, guys. Ogun, good to see you when we see you, and catch you guys on Slack if there's something else that you run across you need some help with.
Okay. Look.
Yeah.
I'm gonna turn this off, but like, can we chat real quick about these other things that I was mentioning about the whatever we. I mean, you can listen to this too. It's just don't want to add this to the meeting because we already discussed this. The idea of having an umbrella organization for all our softwares and stuff like that. So I'm gonna just stop. So this is not part of this meeting for bureaucratic purposes.
Yeah, it sounds good. Switch it off, and we'll keep talking.
All right. I'll call Muluk. I mean, do you want to participate on this, or you have something?
I actually have to go.
Yeah, you better.
Next time. Right?
All right. Bye, guys.
See you.
See ya.